Hi guys, let's see an interesting problem today. So this question is question number 30 from GATE 2020 and paper 1. So let's just see what is the problem. So we are given a stress structure like this with its particular properties, that is length and EI, and as you can see, uh, force P is applied at a particular angle, and the main question is like, what is the smallest value of P at which any of the truss members will buckle, you know. So we are given four options, so we need to solve this using buckling theory, Euler's buckling theory. So if you want to know about these truss members, you can look into Mechanics of Solids by Professor Priyanka Ghosh, IIT Kanpur, NPTEL lecture. Uh, Otherwise, also you can find other relevant videos always. And so this particular problem, first we have to see what is it telling. So uh, let's move forward. So going further into the problem, okay, so let me just draw this here again. So I'm having four structures like this, okay, and a center structure, truss element like this. Okay, so my force, let me use this. My force is somewhere here in this direction, okay. Yeah, so let me take this angle as theta. So yeah, let me name these points A, B, C and D. So you can see that at point A, what is happening? This is your point A, this is your force, so if you take this as this is P, so you'll get P, uh, so P sine theta, here P cos theta, right? And this is your member. So you can see that uh, P sine theta is acting along this member, okay, while P cos theta is acting along this. So let's say A, B, this is D, okay. So now if I say that, I can say that the force on member AB is actually P cos theta, and force on a member AD is actually P sine theta. So similarly, if you draw for at point C, what you're getting is actually, so this is your member, okay, and let me take this again, this is P, and here theta is this as given here, theta, okay. And so what you get is P cos theta, P sine theta along this direction, right? So again, what you can write is, you can write F, so here it is C, D and B, okay. So FBC is equal to P sine theta FCD is equal to P cos theta. So if we take the other member also, that is here BD. So what is happening here? So let's do it in another color. Yeah. So you have here it is FAB. So that is P cos theta, and here it is P sin theta. Okay, so what is your FBD? That is square root of P sin theta square. That is basically the resultant, and P cos theta square. So when you solve this, the force acting on FBD is actually P. So this is first point to be noted. So let me just zoom out a bit. So now what do I get here? So this is first thing to notice. Now second thing, to see the overall picture. That is, you're having this, you're having an element like this. So your forces, okay, yeah, you need one more member, yeah, okay. So now your forces are going to be like this. So forces are going to be like this and like this, right? The directions that we took here, yeah, similar way your forces, since it's a pull here, your force components, how it will act, that's what I am actually drawing. So here and here, and what will happen to this will deform like this, so it will be like a diamond shape. Yeah, good. So now the forces, like I showed, it will be like this, and here what you will get is actually a compressive force in this particular. So you have B and you have D. So your FBD is actually a compressive force, which is actually equal to P, right? So your FBD is actually is equal to P, which is a compressive force. So now what is happening? So let me just take this out of the screen a bit. Yeah. So let me draw this again. So I'm having a rod like this, element like this, and it's under compressive load. So the element is BD and the force is P. Okay, so it is under compression. So using Euler's buckling theorem, what do we get is your compressive load for buckling is in general pi square EI by L square, right? Let me take a better one, yeah. So here the load is P. Okay, yeah, before that, here what we have is, instead of EI, what we have is 4E, and instead of L, what we have is L root 2, right, for this particular member. So that means your load, if P is your buckling load, it should not fail, right? That's the question. So P is your buckling load, pi square into 4 EI by L root 2 square. So now when you actually solve this, what you're going to get is 2 pi square EI by L square. So this is actually your final answer. So if you check out the question, let's check out the question. So if you check out the question, so you can see that your answer is actually C. So C is your correct answer. So thank you. Thank you all.